So hello, welcome to this program brought to you by the Networking Channel. We are very pleased to have you today to discuss about what is in 6G, and in particular how this is going to be addressed in Europe, so that the important use case that are supposed to be the challenging ones by the year 2030 will be addressed. So today, I'm very pleased that we have a wonderful panel, and in addition, I have a guest star with me in order to balance the European representativeness. We have Jim Kuros from the US, and I'm very pleased that we have this excellent panel. So today, with us, and in order to speak about the European policy, we have Bernard Barani. I know Bernard since long, I can say Bernard, because we have about the same age. And he has been orchestrating telecommunication research and innovation in Europe since a long time. So we're very happy that he accepted to join us to present how Europe is going to develop its policy regarding 6G research and innovation. And then we decided to put a strong focus on the Hexa-X project, which is the 6G Europe flagship project. And we have with us Nokia and Ericsson. So Mikko, who is the coordinator from Hexa-X, and Patrik, who is strongly involved as well, are going to share with us what they did achieve in Hexa-X-I and how they are going to develop Hexa-X-II. So this being said, as you know, the program is recorded. We also have a Slack channel. All the information is going to be shared with you on the chat. And if you have questions, please use the Q&A in the Zoom so that we can see the questions and we can manage sharing this question with the panelists. So this being said, I would like to hand over to Bernard. I'm going to share the slides of Bernard. Bernard, the floor is yours. Please, go ahead.
Many thanks, Serge, for the kind introduction. I hope you can hear me.
Everything is fine.
Everything's okay.
You and hear you.
Okay, so good afternoon or good morning. I don't know exactly where you are. Many thanks for the very nice opportunity to express to a wide audience what we are doing in Europe in the context of 6G. So personally, I am working with the European Commission, and I am at this moment in time responsible for the work program, the research work program of our so-called SNS initiative that you can see on the screen here. So it stands for Smart Networks and Services, which is the canonical name of the initiative that we have started already more than a year ago, which is supporting 6G research and innovation, or beyond 5G and 6G research and innovation in Europe. So next slide, please. We started to work on this 6G story, or to ask ourselves and scratch our heads what it is that we are going to do in this domain several years ago, already 3 years ago, but very quickly we ended up with a set of notions that we have to take into account when we design our next research actions. The very first important element in our view is that the geopolitical scene has changed, and we have to give, let's say, accrued importance to cybersecurity aspects and to supply chains. Which means that from our perspective, when we look into research these days, we try to be much more complete than what we did in the past. That means we try to address from really the very low level at components, microelectronics level, up to the service delivery chain, which is primarily based on cloud or distributed cloud technologies. On the industrial side, there are also very important developments. You probably all know about Open RAN, disaggregation of networks, and the idea of implementing network functions in cloud. And this is something where Europe has a certain position, which is not necessarily commensurate with the rest of the world. And this is something where, of course, we have to be very careful and look into it in such a way that we drive our research in the direction of having some, let's say, ecosystems developed in Europe in that particular domain. There are other elements which are coming very strong on the agenda, such as sustainability and societal issues, primarily energy efficiency, climate change. This is a very topical subject these days, which we try to, let's say, input into our research action much more systematically than what we did before. And also from the user side and the business models, maybe we see also more emergence or more importance of new industries such as vertical users or micro operators. So there are a number of potential use cases which are coming that we did not necessarily expect when we started our 5G actions several years ago in 2013. So next slide, please. So on this basis, we initiated a few set of exploratory projects already in 2020. You have the name of these projects on the left-hand side of this chart under the banner of the HexaX flagship project, which is the kind of overall system project. And we use this set of projects to develop what could be called the 6G vision. What is 6G? What we intend to do. And this is something that we did already more than a year ago, taking into account that today there are no 6G agreed visions. I mean, ITU is supposed to develop the equivalent to the recommendation M2083, which, if you remember well, was a so-called triangle for 5G with the EMBB, LMC, and LMTC, sorry, the three type of classes of use cases. We don't yet have that in the 6G domain. The work is progressing a lot, but we started to do our own, let's say, vision before that. And we came up with this vision primarily under the banner of HexaX, where you could see 6G has a combination of several worlds, the physical world, the digital world, and the human world. The main idea behind, and this will be much more developed by the colleagues of the HexaX project, the main idea behind that in the future we can think of massive digital twinning of the surrounding world. And this digital twinning is not only to represent the world that surrounds us, but also to have intelligence and to understand what is happening around us in such a way that through their digital representation of the world, we can act upon it through in this physical world by understanding and taking actions, which requires, of course, a lot of new technology such as artificial intelligence, which is the elephant in the room in this particular type of scenarios. And on this basis, the colleagues of HexaX have developed a number of use cases and underpinning technologies that they will develop themselves. And under this vision, of course, we put a lot of interest and focus on the sustainability issues, and in particular, energy efficiency type of issues. So next slide, please. We are working against a roadmap which we try to map or to parallel with the standardization roadmaps. So there are some expectations that 6G will become a topic at the level of big standardization institutes such as 3GPP at the level of release 20, which you see at the bottom of the screens around 2025. So it means that we now have about two years period to finalize and to make it clear what kind of technologies we want to develop for 6G, to realize the vision, to realize the use cases, and what is it that we should bring to the standard. So today we work primarily under the so-called phase one, which is exploratory technologies mainly, and exploratory architectures also. We have a lot of work on architectures. And then we will follow that with the so-called phase two, which will look into detailed design and system optimization, so full system type of project. And the phase three, which will be more towards full pilots and very sophisticated pilot and experiment systems. So that's the roadmap we are working against. It's a bit linear. It's a bit classical, but it's open to flexibility and let's say reshuffling or restructuring in case things develop not exactly as we have predicted. So next slide, please. So of course we put a lot of focus also on the international cooperation. So the industry association, because we are working with an industry association in Europe, with which we are working to develop this research agenda and to implement it. This association has signed a number of memorandum of understanding with several regions of the world, with which we have several political agreements, in particular Korea, Japan, and the US. In the US, we are working under the TTC, Trade and Telecom Council, which is a kind of political umbrella where EU and US cooperate on ICT matters. So for us, it's important because we are in a pre-standardization mode, and we believe that it's important to have global cooperation to try to have very early a consensus of what could be the best technologies to bring to the standardization bodies. And at the same time, we work with a lot of let's say representative industry associations in various domains: automotive, industry, media, public security, PPDR type of systems, satellites, and so on, to try to have the user view and not to involve the users at the end of the process, but to get their views very early in the process in such a way that also Europe has more weight in the standardization process with the, let's say, vertical industries and the user industries. Next slide, please. So we had already under our initiative a first call, which terminated in June last year. It was about 250 million euro investments. Out of this call, we finance 35 projects which are now running. And you can see on this set of slides, without going into the details of the set of slides, we work in streams, and we have 3 key streams for 6G. Stream A is a little bit special, it's a shorter stream, but stream B is really the research stream. Stream C is the stream under which we try to develop already now in Europe experimental infrastructures, and stream D is a stream under which we already very early try to involve the vertical industries and the users in such a way that they can use and test the technology from the onset. So for the stream C, which is experimental infrastructures, for those of you who are familiar with the Genie model that was pioneered by the NSF several years ago, we try to use the same spiral type of model where over time we complement the infrastructures with new capabilities as they become available and more mature, and pertaining to representative technologies for 6Gs. So this, the pie chart on the right hand side gives you an idea of what kind of technologies we are supporting today. Few words on that. On the radio access networks, we are having a lot of terahertz or sub-terahertz type of activities. Microelectronics, again, we look very much into these type of technologies for covering higher frequency bands. But for instance, we have a lot of activities in architectures, and here in architecture, the bulk of the activity is on, let's say, what the stakeholders call AI native type of architectures. That means the network is a very big data collection platforms which can be used to optimize the network end-to-end in real time. Some concept you see already appearing today with, for instance, the RIC, the intelligent controller in the ORAN or in the Open RAN domain, or the NWDAF functions in 3GPP. But what we are missing is an end-to-end view of AI modeling and AI, let's say, management of the network. And a few other elements we are supporting. For instance, security. What is very important for us is to understand that future implementation of networks are very much cross-domain. So you can have a network implemented partly with a communication service provider, with an hyperscaler, with a vertical, and question being how you ensure security across all these business domains and technological domains. So in the middle pie chart, you see the type of vertical industries we are working with, and then on the left-hand side, this gives an idea of, let's say, the type of stakeholders we are working with from the industry and the academics. So academics, of course, very strongly involved in these early research stages. So next slide, please. Voilà, this is the structure of our next call. So for 2023, the call is open. And for 24, we are working now on the definition of the call that we will initiate for 2024. But without entering into the details, so you have the figures, you can study the figures once you get the slides. I suppose all this will be available publicly. What we are trying to do compared to the first set of actions that we have, is that we are trying to enhance the aspects which are related to international cooperation. So that means that we are designing a dedicated cooperation action with the US, with Japan, and with Korea at this moment in time. We're trying to boost certain sectors from the vertical industries which are not so well covered. And we are trying to also boost the microelectronics sector, because we believe that both from the perspective of supply chains and from the perspective of what we call EU sovereignty, this is a very important domain to work on. So next slide, please. So that's my final slide, just to tell you that if you want to have a few more ideas on the type of actions we are financing, you can go to our website and you will have here all the presentations from 4 webinars that we ran recently, where you have presentation of all the research actions that we are financing or supporting at this moment in time. And of course, our next conference in June, the EU CNC and 6G Summit, will also be a nice opportunity for anyone interested to know more of what we are doing in Europe. And with this, I will hand over to the real people. That means the HexaX people.
Thank you so much, Bernard. So again, I would like to invite the audience to start asking questions if they have some on the chat, but we will, of course, handle those questions at the end. And yes, we're going to hand over to Mikko and Patrik. Mikko will start first as the coordinator of this flagship 6G European project. So today we are lucky that we have Mikko and Patrik, so Nokia and Ericsson, but in HexaX you have 44 partners. So I think it will be very interesting for us to see how you develop this important initiative. So Mikko, the floor is yours. And we can see your slides very well.
Okay, good. So thank you, Serge, and thank you, Networking Channel, for the opportunity. So yes, a pleasure to present today. So as said, Mikko Uusitalo, coming from Nokia Bell Labs, Finland, and leading a radio research department here, and then being the overall lead of this European level 6G flagship initiatives, Hexa-X, Hexa-X-II. And happy to tell you more about them. Hexa-X is obviously the first one of these 2 projects that started on structuring, framing, developing technology and connectivity needs as then the first flagship initiative, bringing together industry, academia, to jointly create understanding, jointly create momentum around 6G. So we are a strong consortium, as said, Nokia overall leader and Ericsson. So Patrik going to talk soon is then the technical manager. And we have a strong R&D intensive operators, technology providers, SMEs, and of course then high quality academia. And here you already saw from Bernard information on this time scales here we are talking about. And so Hexa-X is part of this initial phases of structuring and framing. We started a bit more than 2 years ago, and we are a 2.5-year project, so running until end of June this year. And I'm now going to tell more about this Hexa-X, and then later on we will be telling you more on Hexa-X-II, which is then this next phase, systemization, after which there is time for standardization at the end of this Hexa-X-II. Technical specification ramps up mid-2025, and then the commercialization towards the end of the decade. So it takes around 10 years from these initial stages of research until commercialization has been roughly similar for earlier generations as well. And there are good reasons why it takes this type of time. So the vision, also you saw from Bernard some good information on this vision. We have been ramping up that 6G is to connect the physical, digital, and human worlds with the fabric of 6G key technology enablers. So humans are of course part of the physical world, but here emphasizing that the technology, the services is developed for humans. But then the essential part is that there is this connectivity between the physical world of objects and humans to the digital world where models are built, and those models then enable better operation and proactive operations in the real world. key values underlying our work, sustainability. So whatever we do towards the future needs to be sustainable. And also, in addition to technology itself being sustainable, we need to see how could we help other sectors of society be more sustainable. So 6G for sustainability. Also key value inclusion, how can we increase the amount of population having an access to wireless and digital services. And then trustworthiness. Of course, as more aspects of life get digital, get wireless, so this needs to be taken into account in the design from the very beginning. On these research challenges, we have gone way forward from those and have results in many of these areas, and happy to tell you something on this. Of course, from our website you'll find a lot more. Why is then 6G needed? So here is then information on these use cases grouped into use case families. So one aspect is this enabling sustainability use case family on the lower right. And then moving to this use case family, massive twinning. So this is the connection between the physical and digital worlds. We currently have digital twins, so models in digital form or physical reality, for example, a machine. And then how can we bring this to the next level, to this massive twinning, so where we are synchronized way modeling in real time entire industrial complexes, cities, so on. And with this, we can better plan and design the operation and do proactive maintenance, so detect problems before they occur and have proactive action on those. Telepresence related to a human or set of humans being connected with each other, of course independent of location, using any necessary senses. Also being connected with the digital world, being connected with some that does not exist in physical form anywhere, but you can like a test how would that be in the physical form before you realize it. And you can apply this in this kind of work context, mixed reality co-design, or embed yourself in some cultural events, sports events. Robots to cobots use case family. So we are having a robot serving a human or set of humans, also anticipating the needs with artificial intelligence and serving the needs. And then set of use cases focusing on more local connectivity, where trust trust and resilience are in a strong role. So then, of course, when we have these challenges with the use cases, we need to understand what kind of key performance requirements represent the requirements for the technologies, and then map that how far we are with at each point of the development with technical enablers we develop. We need to look at the traditional ones on capacity and so on. Need to look at end-to-end key performance indicators, for example, energy efficiency, very central. Need to look at new capabilities like sensing. So with 6G technology, we expect networks that can sense. So they can, in addition to being for communication, with the communication hardware as a side product, you can get information also what kind of objects there are around and how they are moving. Then we also need to look at some challenging cases related to, for example, sustainability, where it's difficult to put up quantitative measures, but also, of course, aiming to move to that direction. So look at some key value indicators, also underlying the key values we have for sustainability, inclusion, trustworthiness. Then last year spring, we published the first end-to-end architecture for 6G. And this year, up to mid of this year, we are going to publish then the final version of that coming from Hexa-X project. And here is some information on this architectural principles. So we are targeting increased network intelligence, meaning architectural principles on exposing the capabilities to end-to-end applications and designing for automation. And then this we are targeting to enable with this architectural enablers of ever increasing role of programmability in various parts of objects in the network automation and related analytics, intent-based management, and with this increased role of artificial intelligence in all the layers of the network, so having the AI also available as a service. Then with the aim for increased network flexibility, so principles, flexibility, scalability, resilience, availability, those targeted tend to be fulfilled with architectural enablers on subnetworks. Subnetworks being some very local networks around a human or set of humans or machine. And then looking at the integration of various non-public networks with public networks as additional enabler, and also look at local connectivity, look at device-to-device, mesh, and also non-terrestrial networks, and look at the various roles of them as an enabler to increase flexibility. For the network efficiency as principles, exposing interface, having them as service-based, separating concerns of network functions, network simplification in comparison to previous generations, with then enablers on efficient radio access network, core network signaling, function refactoring, and computing as a service. We have also published this figure representing this end-to-end network architecture, having in these lower layers new enablers for example, for the sensing, for AI, and then between these in the network service layer, having the cloudification extending all the way to the extreme far edge, including the end user devices, and all of this serving the generation independent application layers. And then having this management orchestration strongly based also on AI, cut across all the layers, have the security also being an important role across all the layers. Spectrum, of course, for wireless communication is in very central role, and novel things that you will hear more about is going to these higher frequencies to address to the needs of increasing traffic. This is important to understand, but in terms of economical feasibility and also technical feasibility, we expect 6G to start from similar frequencies as current generations, with also nearby frequencies of this 7 to 24 gigahertz, and very important, especially 7 to 13 gigahertz, important opportunity that we should target to with 6G. Also, increasing intelligence, enhancing the efficiency we are using the spectrum, and also other ways of extending the spectrum utilization to address the increased needs for efficiency. Looking at relaxing some models, looking at then better usage in terms of time and space of locally available spectrum, and so on. And then my pleasure to hand over to Patrik.
Thank you, Mikko. So my name is Patrik Rugeland from Ericsson Research, and as Mikko mentioned, I'm technical manager in HexaX. I'm going to tell you a little bit more on the technical aspects. So as Mikko mentions, the higher frequencies will be very interesting to 6G. And in the project, we identified what these millimeter wave and sub-terahertz frequencies may be used for. And we can classify this into short range, so classical communication with device to infrastructure, device to device communication, but also long range wireless links. So front haul, mid haul, and back haul. You can have fixed wireless access where fiber is not convenient, or you can have mobile wireless links where fiber is impossible, for instance, connecting to non-terrestrial networks. But we also have this aspect of using sensing with the radio waves. So using the radio waves to localize and map the environment, or even do some spectroscopy where you use the absorption or reflection spectrum of the received signal to see what's around you. Next slide, please. So looking at some aspects of what we believe 6G will be capable of. So we have a target on the round latency should be improved by around a factor of 10 compared to 5G. So an one-way latency of about 100 microseconds. And in the project, we did some calculations on what would be required sub-carrier spacing and bandwidth to achieve this. And we see that with around 2 gigahertz bandwidth and sub-carrier spacing around 500 kilohertz, this can be achievable. For bit rates, we did a calculation looking at what bandwidth would be required and using this as input to the power models we have. And we see that the bandwidth requirements are quite steep. But apart from these separated latency and bitrate requirements, there may be applications where you need both at the same time. And there it's the bounded end-to-end latency from the application, which is important, not just the air interface latency. But here we are looking at some specific deployments where you can deploy the core network and perhaps the application networks in a closed non-public network. So then the transport latencies will be negligible. We also have a requirement on the radio positioning, so sub-centimeter accuracy. And we've started doing some work on this. There's still some way to go, but we're looking at different methods how to achieve good accuracy on the positioning. Slide, please. But as I mentioned before, one big part of 6G will be to reimagine the purpose of the radio connection. For the past decades, radio has either been used for communication or for sensing in radars. But now that we go up in frequency, we start using frequencies that have traditionally been used in radars. So this gives an opportunity to do both at once. And can you, at a low cost, introduce this radar sensing functionality into the mobile networks with just some software upgrades, since you anyway have the radio hardware in the devices and the network? And here we can benefit from a huge number of network nodes and devices that can sense the environment. And can we extract the sensing information for useful applications? And here you can imagine some new and enhanced services, location-based or enhanced existing services. They can also use the sensing information to improve the network performance. If you know where the device are located, you can do beamforming to do preemptive handovers, for instance, or you can reduce the intercell interference. Next slide, please. Another aspect the project has been looking at is some vertical applications and interesting industrial scenarios. And here we have two types of use cases, both very high dependability and very low energy and sustainable coverage for IoT. And one aspect we're looking at is this communication control co-design, where the network take into consideration the application need to see how much communication needs you have. So you have a joint optimization of both the communication and the application control signaling so that you can most efficiently use the radio resources. Another aspect is, go back. Yeah. Another aspect is this radio-aware trajectory planning. If you know where you have coverage in the area, can you steer, for instance, a drone to have optimal communication coverage during the whole path? Go to the next slide, please. Another aspect which will be very important in the coming years is AI. So the overall trend is AI will be everywhere. And can we utilize AI in the networks? So how can we integrate it to automate the management and optimize different resources and KPIs? And the consequence of this is that we will have AI models throughout the network. And these need to be trained, and you require data that needs to be in the right place at the right time. And we need to ensure the security of this data and the integrity of these AI models. Next slide. And if we look at the air interface, if we can use AI there. So one aspect we've been looking at is how to improve the network performance using AI. And here we have an example of how we can do beam scanning to do a compressed sensing-based scanning, which requires fewer measurements than just a sequential beam scanning. And can we build a 6G network as an AI platform to provide AI as a service? And how can we efficiently have multiple AI agents interacting throughout the network? Another aspect of AI is to improve the network sustainability. If you can predict where you need resources, where you need the data, you can reduce the computation and communication needs and save energy. But as with any technology, we need to ensure the security and privacy and the trust in the AI. So how can we ensure that the data is secure and no information about the users leak to unauthorized people? Next slide, please. So as a conclusion for HexaX, we conclude that 6G will be much broader than just the radio access technology. It will be a flexible platform providing connectivity, data, compute, intelligence, and sensing. And you can find our deliverables on the HexaX.eu website to read more. So now I hand over to Mikko again.
Thank you, Patrik. So then we would be moving towards the successor project, Hexa-X-II. It is the next European level 6G flagship, only started beginning of this year, and it will continue based on the earlier Hexa-X work, but what is changing is that gradually it aims to then build the systemization view. So what really is important and what really should be selected to be part of 6G. It is funded through the smart networks and services that Bernard was earlier presenting, and it has an enhanced group of organizations, so up to 44 partners. Nokia continuing as overall leader and Ericsson, Patrik as technical manager. And here you can see how we are really well covering different types of players, from academia to SMEs to large enterprises and different parts of the value chain. And just a reminder on the timeline, so we are now then moving towards systemization, so narrowing down what really is part, what is relevant, what's important for 6G specification, that will then start in standardization in a higher volume mid 2025. So in other words, so we are a flagship towards the 6G platform and system to inspire digital transformation for the world to act together in meeting needs in society and ecosystems with novel 6G services. So building on top of this earlier work of Hexa and other projects, taking a new refreshed look, extending also the team who is exposed to the interaction on aiming to understand the use cases, services, requirements, bring the value to society with these, and then look at these different activities, look at other projects, and look at this needed technology then to integrate that into system blueprint and platform. And here one central item is then to work with the other projects as is taking place in this EU-funded frameworks. There are various tools with which the projects can add more than what is the simple sum of the projects via beneficial interaction, and also very much looking forward to continuing the interaction we've had also outside of Europe already in the previous project. So then with this introduction, handing over back to Patrik.
Thank you, Mikko. So as HexaX-II is continuing the work from Hexa-X, where we saw that these key values will be very important. So a large part of the project will be focusing on what value 6G can bring. And here, sustainability will take a central role. And not only the environmental sustainability, but we'll also be looking at the social and economic sustainability. And this will guide our work to continue the work on use cases, defining these, narrowing down the requirements, the KPIs, and defining these key value indicators. And we will also do an analysis on the stakeholder and ecosystem, so see which will be the players in 6G, who will use it, who will sell it, who will benefit from it. And we will have an open discussion with the society at large to see that we can anchor 6G in society so that we can get a wide acceptance of the future mobile network. Next slide, please. So a large part of the work will be focusing on defining this network platform blueprint. How can we take all the pieces of 6G and defining a full 6G network? And we will take the input from the previous projects, other SNS projects that will be running in parallel, and also part from the work being done within HexaX-II. And from this, we will do a system validation through a series of proof of concepts that will build out and test different parts of the end-to-end system. We'll also be looking at different end-to-end aspects, such as this service management automation, looking at how the radio interface and protocols will look in 6G, how they need to be changed from 5G. And also looking at the system level security and resilience. How can we ensure that the 6G system operates as it should? So next slide, please. So some of the technical aspects we'll be working on is this architecture design. And this will continue the work from Hexa-X. You recognize this mesh and device-to-device in the center with new access methods, with device-to-device and non-terrestrial networks. But we'll also see how the architecture will incorporate a data-driven architecture, how we can integrate the AI, as well as these beyond communication aspects, such as sensing and computation. How will the architecture look like to utilize this? And to make the networks more efficient, we will be looking at how we can make a modularized network and see how we can build this service-based network, not only in the core network, but bringing this all the way down to the radio access network. Next slide, please. For the radio interface, the project will design the radio interface, incorporating aspects, both of this high frequency communication, but also how to incorporate this joint communication sensing and different spectrum access solutions. And we'll be looking at how we can integrate the AI in the air interface design and how we can to see if we can utilize real-time AI to optimize the air interface. Another important aspect for 6G that was not present in the HexaX project is the role of the devices. So how will the 6G devices look like? Will it only be a continuation of the smartphone, or will we have these headsets everywhere? And we will be looking at how the infrastructure will support these devices. We'll also be looking at the difference between generic and specialized hardware to see if we can build system on a chip with generalized hardware. And we'll also be looking at this extremely low power devices and extremely cheap devices that can operate with energy neutrally. So they harvest energy from the environment and see how the network can support this. Next slide, please. And finally, we'll continue the work on enhancing the network management, incorporating AI and ML throughout the network to see how we can achieve real-time zero-touch control loop automation of the network to enhance the flexibility and efficiency of the network. And we'll also be looking at this inter-domain and computing management to be able to move the network computations to where it's needed. Either have cloud resources doing the computation, moving it to the edge resources, or even out to the devices doing the needed computations. And throughout this, the security and trustworthiness of the network is very important. So next slide, please. As the project has just started in the last few months, we so far haven't had any deliverables ready. But the first deliverables you can expect in July on the environmental, societal, economical drivers and goals for 6G and the draft foundation for the 6G design. For the technical parts, we will have a first internal deliverable in the summer, but the first public deliverable will be available at the end of the year. So thank you all. We have time for some discussion or questions.
Well, thank you so much, Patrik and Mikko. Quite impressive when we look at the broad scope that you're addressing in Hexa-X. So I suggest that we use the 15 minutes that we have left just to exchange with the audience. And we have seen quite many questions popping up. So maybe I will try to select a few that have not been addressed so far. So there is one question from Akima, which is about what are the limits of 5G in the considered use cases for 6G in Hexa-X? We have been addressing some use cases, but what are the limits of 5G?
So limits of 5G or 6G seems it was limits of 5G. So 5G is pretty much, I mean, of course, these generations are not like a monolithic technology. So when the first version of 5G came, it was like the first release and those parts that were possible to implement and deliver to markets in the beginning. And then in the technical specifications, there are through years, there is various forms of enhanced versions, and also 5G is being enhanced all the time. With all these generations, there is a certain level that it reaches during these enhancements until then the new generation begins to come. So there certainly are kind of already quite visible limitations in terms of capacity, in terms of latency, and in terms of many other of these indicators we have been talking about. I don't know if Patrik or Bernard would add something to this, or if there would be some additional specification on what is the background of the question.
No, I believe the question is also about, what is 6G evolutionary with respect to those use cases, or what is really transformative? I guess that's part of the question. And I see Bernard raising his hand.
Yeah, I can give you my perspective because this is something on which we had several discussions with stakeholders. I don't think that there are uniform views on that, but when you start from 5G, for instance, 5G is established with a certain set of KPIs. So you can take in factories environment, for instance, you have reliability KPIs of the so-called 5.9, 99.999% of the time reliability or availability. Some people in industrial environment tells you we need to move to 7 nines or to 9 nines. This is not enough for our process or for our staff. So it's not every factory which needs this, but some use case appear with, for instance, reliability or availability requirements which are higher than what we see in 5G. The same if you take scenarios with digital twinning of surfaces. I mean, if you want to have real-time digital twin of a surface which is around you, and if you imagine that you reproduce this with a camera type of sensor, which would have an 8K type of resolution, like what you find in TV sets, you will easily find out that when the surface around you expands, you will have to deal with terabit type of data rates, a very huge type of data rates, which 5G potentially comes at some sort of limits. So there are a number of use cases where you can identify KPIs that go beyond the 5G so-called KPIs, those that were identified in the recommendation M2083. But it's part of the normal generation game, if I can say so. If you look at the way generations have evolved, in every generation, 4G, 5G, you find two types of things. You find new set of use cases, which are completely new and enabled by the new generation, and enhancement of what the previous generation or evolutionary. So this evolutionary / disruptive perspective is always there. I suppose that here, if we talk about something which is definitely not considered in originally in the 5G design, what Patrik mentioned, such as joint communication and sensing, is certainly type of this new breed of applications that today is not necessarily directly available from a 5G evolution. That's my perspective, but maybe I'm not in line with the...
A short one, Mikko, maybe.
Yeah, thanks. So that was a good answer. And to continue from there, something then that is maybe more different is also this aspect of sustainability. So there is strongly increasing needs for addressing the sustainability. This is something that, and these value-related aims that is setting new kinds of requirements that have of course always the energy efficiency has been central, but it's a wider look at the sustainability challenges that we need to address and cope with.
Thank you, Mikko. So I'll go to the next question from Maurice. It has been partly addressed, but I believe you can complement. So we know that terahertz radio channels are adding highly fluctuant characteristics. So this will necessitate real-time cellular planning. Do you intend to consider RIS technology and AI for that purpose?
It will be a part of the scope, but not a major part. But I know that other SNS projects have a very strong focus on RIS for terahertz, and we will consider aspects coming from other projects and see how they will be incorporated. But it will not be a major focus on the Hexa-X-II. But of course, it's an interesting research topic.
Okay, so you have another one here from Hakan. What are the envisioned new evolved interfaces toward the application developer enabled by 6G? So basically, from the user point of view, how do you see this being evolved in 6G with respect to API for the users?
Maybe in many ways for the application layer, there are many things that are generation independent. Something which is maybe having biggest impact is that as there are some new things that were not possible before, for example, related to this sensing and more accurate positioning. Then the new functionalities that need to be enabled also at the application layer.
Okay, that's not an easy one, huh? But at least it will be could be discussed in the Slack channel. So there is a short question, maybe not with a short answer. What role network slicing will play in 6G?
Whoever. We've seen it started to play a big role in 5G, and HexaX project is not looking at it, but we expect that it will continue to play a role in 6G, but we haven't evaluated it.
Okay, there is one from Rui, and it's interesting because we're discussing this with Jim, who doesn't see, let's say, digital twins as appealing in the US as in Europe. So Rui is asking, how do you see the need for network digital twins in 6G?
In this set of use cases and in connecting the worlds, that's a central item. So the idea here, why this central and of interest is then the possibility to be better able to design and operate and do some preventive maintenance. So detect some problems that are likely to happen in the near time in the physical reality, and then be able to act on those. So this is an opportunity that could be made available in a wider extent with enablers in 6G. And of course, then it remains to be seen in the future that what is the winning way of using these enablers, and how strong role will this type of approach play?
Okay, quite a lot of questions actually. So I have to just select a few. Could
maybe
you
say a word about continuing the conversation on the Slack channel?
Yeah, so that I mentioned a little bit in the beginning. So we have a Slack channel that has been advertised on the chat, so that you can continue to ask questions on the Slack channel, and our panelists will certainly be happy to address them if time allows. So we have a question here, which is about, could you expand a bit the potential of a better knowledge of communication channels and AI-assisted real-time reconstruction of communication channels?
Yeah. So AI has been studied in this context and in this role, and it's an interesting question that how good information can be obtained via AI, and then what would be the best ways then to use that information. Yes, and how to do it in real time. So we have some information on that available in our current and future deliverables.
Yeah, again, a lot of questions because we are all struggling with this vision and challenges about 6G. So one from Patrik, who I'm happy to see here. For the moment, AI robustness and explainability concern don't fit well with the high reliability constraints and highly critical services envisioned by 6G. Patrik is working for the, let's say, the air traffic control academics bodies.
Yeah, so here we see a balance between the new KPIs and the traditional KPIs, that we need to do a trade-off balance between the trustworthiness, the explainability, and the traditional performance. And for dedicated services, we need to design the system so that we have the correct level of robustness, explainability, while still fulfilling the reliability constraints.
Okay, just another challenge, again from Maurice, because it's a comment, but I think it's interesting because it's a bit controversial. Reaching 5 nines level reliability in wireless at such frequencies and assuming mobility sounds totally unrealistic.
So then it's a good challenge for researchers.
Good, that's a good answer, Mikko. Okay, there are still a lot of questions, but I would like, because time is flying, to
1 minute to go.
Yeah, so to hand over to Jim for last question before we move to announcing the next program.
Oh, golly. First of all, I wanted to say thanks very much for really fascinating presentations and the conversation. And maybe I wanted to follow up on something Bernard said earlier. I came into this wanting to know, okay, what's the delineation between 5G and 6G? and also sort of in comparison to the internet where there hasn't been this notion of generations. And yet when I look at 2G to 3G to 4G, you can sort of see almost step functions in technology. And I guess what I take home from the presentations today, and again, thank you, is that the technology and the research is pushing forward on so many different directions that at some point there's going to be a line, and maybe it's release 22 from 3GPP. At some point somebody says this is 6G, but I guess other than the sensing that we heard about, communication and sensing, sort of very step function like changes in technologies may have been part of the past, but going forward, it's more evolutionary. And I don't mean that in any negative sense at all. It's just that technology is progressing, and maybe future generations will be less discernible from previous generations, just like in the internet, no one's ever said, well, after RFC 12,000, it'll be internet 4.0. So is that maybe I'd ask Bernard, is that a reasonable way or reasonable thing to take home from the conversation today? And thank you again.
Well, it's difficult to predict the future. If the G system will continue the way it is with one more generation every 8 to 10 years, or if something more linear or more internet-like will happen. What seems to be my understanding is that Gs always come with a new generation of radio. And so far, we have always seen new progress in the radio domain whenever a new G was coming. And this maybe explain the cycle of 8 to 10 years, because investment in radio are huge, and research is very costly, and there is and also because the operators don't change their radio system every 2 years or every 3 years. So this is not necessarily something that corresponds to the internet type of cycles. Now, if something more, let's say, a little bit different from this pattern emerges, then of course things might change. But this is only my modest perspective, and I don't pretend to represent a wide European agreement on that. Certainly not.
All right, thank you.
Excellent. Mikko, can you stop sharing? I would just like to take 30 seconds to share with the audience our next program. As you will see, it's not completely, but somehow related. We are going to have, in 2 weeks from now, as you know, this is our pace at the networking channel. So in 2 weeks from now, at the same time, we'll have another conversation that is related to next generation research group of the O-RAN Alliance. As you can see here, we have different panelists that are going to address what kind of topics are really key within O-RAN Alliance related to research. So please register and join us for the next event. And again, Jim and I and everyone would like to thank the panelists and thank the audience for this very interesting and stimulating discussion. And again, you can replay in case you were not able to attend directly on our YouTube channel. Thank you so much, and enjoy the day, the evening, or the night, wherever you are. Bye-bye.
Thanks a lot.
Bye-bye.
Thank you. Bye.
Bye.
Bye-bye.